Okay. We're going to deal with distance formulas and equations of circles. The very first piece we're going to do here is a distance formula is actually derived from a specific trig formula. And the trig formula has to do with, oh my God, there she is. Go away, out. With right angle triangles. Get out. Kick the dog out. Okay, we have a right angle triangle, and we have a relationship with a right angle triangle that says that one of the legs A, one of the legs B has a relationship to the hypotenuse of the triangle if we set it up like this, where we have A squared plus B squared is equal to the concept of C squared, okay? The distance formula focuses on 2 points. It focuses on a point, we'll call it here and here. And really what you end up doing is you just find out the vertical distance, which gives you one of the legs of the triangle. You find the horizontal distance between the points, which gives you the other leg. And then you square both of them, add them together, and square root to get whatever the hypotenuse of it would be. So an example of this would be something like, let's say this is 2 from the origin, so we'll go actually 2 left, -2, up 1, 2, 3. We'll say that this coordinate is -2 and 3, okay? Which makes this 1, 2, 3, 4, 4 and 0, sure. We'll say that this is 4 and 0. So I have 2 coordinates there, okay? I can use Pythagorean's theorem to solve this. In fact, that's exactly what we're going to do. And I'm going to show you what they've given you as a formula for distance formula and how they're in relation to each other. One of the things we need to do is we need to find the vertical, so the A value, vertical distance. Well, the vertical distance would be the difference between our Y values. Let's call this Y1 and we'll call this Y2, which means this is at X2 and this is X1, okay? So we need to find the difference between the Y values. At a quick glance, it's pretty obvious that it's 3. Okay? One is 3 and the other is 0, so we know that this distance is 3. But just keep that in mind. What we've done is we've taken Y1 and we've subtracted Y2. And that's how we found this value of 3. Okay? And if we have to find the horizontal distance, okay, if you look at it, you might quickly find it by some inspection and mental math. But we can use a similar scenario. We're going to take x1 and subtract x2, okay? When we do that, x1 is -2, subtract 4. That actually gives us a value of -6, okay? Which seems odd. Seems like a really odd distance from a triangle. Now, we would never measure distance as a negative. We'll measure it as a positive value. What's neat about our formula here is it squares. When you square any number, you make it positive. The squared value of any number is 0 or above because a negative times a negative is still a positive. So when we go to plug these in, I end up with 3 squared plus -6, that's a negative there, okay, squared, is equal to c squared, which gives us 9 plus 36 is equal to c squared. I do some addition, 45, I think that's 45, is equal to c squared. And if I want to find out the exact distance here of that line, yeah, I got to square root both sides. So as an exact value, it's root 45, which, what's that going to be? 6 something? 6.7, maybe, something like that. Either way, it kind of demonstrates what the Pythagorean's theorem is. Your distance formula, they usually use the letter d. D being the distance between 2 points. I want you to be aware that the d is actually the hypotenuse of the triangle, okay? And it says d is equal to the square root. Okay, well, we did have to deal with the square root before. Square root of x1 minus x2 squared plus y1 minus y2 squared. They give you this very long but very exact formula, but is actually Pythagorean's theorem just kind of expanded a little. It's the exact same formula, and I'm going to show you that. I'm going to take Pythagorean's theorem now. And remember I said that distance is actually the hypotenuse of the triangle? Well, we usually use c, right? So we usually have c squared is equal to a squared plus b squared, okay? Well, I want to get rid of this squared on this side. I want it by itself, so I square root both sides, which means I now get the square root going to make it very long here, though I don't need it, of a squared plus b squared. But if you remember, and I talked about it, a was the vertical distance. Maybe I should have reversed the two. Technically, with addition, it doesn't matter the order we add things in. A was our vertical distance, so that would have been y1 minus y2. That's actually what a is, and it's still squared. And b was our horizontal distance, which was x1 minus x2 squared. This is still all under the square root is equal to c. This is identical to that distance formula they've given you. All we did was expand it to use points. Okay, so if the distance formula is a little too tricky to remember, as long as you get coordinates and you can turn it into a triangle, I go down until I'm on the same plane here, and I go across till I'm on the same plane, and I find the distances, I can just use Pythagoras theorem, and it will give me the distance every single time. These are actually the exact same formula. Okay, now with that being said, we've talked about distance formula. We got to talk about the equation of a circle. The general form for an equation of a circle is x squared plus y squared is equal to r squared, and r meaning the radius of a circle, okay? So if you have an x or a y and it's not in a set of brackets, the center of these circles are always at the origin, okay? So we know that x squared plus y squared equals, let's say, 49. What this does, it gives me a circle at the origin. So I'll give it a rough sketch, and then we'll go into a graphing software so you can see it a little better. We get a rough sketch here. The center is there. What would my radius be? That's what becomes tricky. Well, remember, we can set this up as its own little formula. Oops. This is its own little formula here. R squared is equal to 49, which means the radius is equal to root 49, and that's a value we can actually get. It is 7. Technically, it's plus or minus 7, but again, we're doing measurement. We usually don't measure things in the negative realm. So that means if I were to give this a scale of 2, let's say that this is 2, 4, 6, 8, negative 2, negative 4, negative 6, negative 8, and we do that all the way around, I'm getting points at 7. I'll go back to negative 7, negative 2, negative 6, negative 8. So negative 7 is probably about here. And then we go 2, 4, 7's about there. Now, by hand, I will not do a good job. I am just not coordinated enough for this piece. I never make something that looks like a circle when I do this. Yeah, that's a really wonky looking circle. But that is technically our circle. And if we jump into Desmos and actually type that equation in, we're going to go x squared plus y squared is equal to 49. Let me zoom out just a little. You see that there's points here. They're all 7s, which means the radius is 7. And that's what's unique about a circle is the distance from the center of the circle to any of the outer points is identical all the way around. That's the radius all the way around. Now, what they may ask us to do is find radius of something, or find the equation of something. Let's go with radius to start. Equation of a circle when they've given us some points. So, for instance, let's say they give us a question like this. They say the circle, that's a C. Circle passes through point. Let's see if they got a nice one here in their work. I'm going to steal one so that hopefully we end up with a nice value. Those ones aren't nice. Let's do, I like the roots over there. We're going to work with a hard one, okay? This one? Yeah, I want to do that one. Is that good? Yeah, okay, so let's do that one. It passes through this coordinate. Negative root 8 and 3 times root 10. That coordinate is in mathematics, we'd call it an intractable coordinate. Oh, I didn't write it on the right page. Let me show you. You're looking at the wrong page here. Here we go. I wrote it down. Circle passes through this point. Negative root 8 and positive 3 root 10. We'll go back to our graphing software just so it, and what I mean by tractability is I don't know where that is on a number line. That's a really hard number for me to imagine. So I'm going to put it up here. We have 8 and we have 3 multiplied by the square root of 10. Okay. Label for me. Where is this thing? There it is. Passes through that point. And look, they've even given us decimal values. Blah. Okay, I don't know. By looking at it, I go, I have no idea the equation of that. But what's interesting is those are x and y coordinates. So when we jump back here, as long as we know the general equation for a circle, this is an x value and this is a y value. So we take the general equation of a circle, which is x squared is equal, x squared plus y squared is equal to r squared. This can help us figure out what our r value is, okay? So I'm going to plug this in for my x value. X becomes negative root 8, and the y value becomes 3 root 10, both squared, is equal to r squared, okay? When I square this, I end up with my 8 value here. So my distance, so we know that we have negative 8 times negative 8 will be a positive, so I have a positive number. And because a root times a root just uncovers the number underneath, we end up with just the value of 8. You can try it on a calculator and you'll see that you'll get just a distance of 8. This scenario here, you end up with, and we'll do this in pieces, 3 root 10 times 3 root 10. And you and I actually talked about this. We can multiply in any order. So 3 times 3 gives us 9. 10, or root 10 times root 10 actually gives us 10. So this ends up being the number 90. Okay, so we get 90 is equal to R2. Okay, well that means 98 is equal to radius squared, which means root 98, which I don't know what that is, 8 something, I imagine, ends up that. So what is it? Oh, 9. Oh, that makes sense. 81 is 9. Almost 10. Yeah, we're really close to 10 there. I'm going to leave it as a perfect value, as an exact value, I should say, because root 98, what that means here is if I go 0 and then I say root 98, that is going to be one of the coordinates on the circle. So I'll put the actual circle equation in again. X squared plus y squared is equal to the root 98. And we get our squared here. Oh, that's cute. And we need to square this value. There we go. We'll notice that this circle is passing right through the point we had. So we use that point to find the radius, which then gives us the equation of everything that we're doing. Okay? So if they ever ask you for the distance of a radius or the equation of the circle and they give you 2 coordinates, what your goal is, and we'll zoom out a little here. There we go. We're going to use our distance formula. That distance formula can help us find what a radius is or the distance between 2 points. And if they give us a point on the circle, we can plug it into the general equation of the circle to find out a radius. Okay? We could have used our distance formula with these 2 values because we would have known there's 1 point here and the other point would have been the origin itself. But it's just as easy to do this to solve our question. Okay? Okay, let's leave it as that.